Okay, now we're ready, I think. Today is Monday, January 7th, and we are doing Eureka Math Lesson 3.8, so Module 3, Lesson 8. We're going to continue right off of what we did right before break. You guys learned how to make equivalent fractions using pictures and models and how to add and subtract them, yes? Very good. Today we're going to add on to that. We're going to use what we know about number lines to help us add and subtract fractions and whole numbers. Today, as promised, we are going to be using number lines to help us add fractions and whole numbers. So you can see here we have a whole number, 1's a whole number, and 1 3/4 is a fraction and a whole number. Yes? Okay, so go ahead and draw yourself a number line. As you know, number lines are lines that have numbers on them. That's why it's called a number line, yes? As you move to the right on the number line, does the value get bigger or smaller? Bigger. As you move to the left on the number line, does the value get bigger or smaller? So if I'm adding, if I'm doing addition, am I going to be moving to the right or to the left? I'm going to be moving to the right. Very good. Okay, so go ahead and get yourself set up by copying down the problem and drawing yourself a number line. Okay, now, the math problem tells me to start at the number 1, right? Because I'm going to take 1 and I'm going to add on. So there's 1, and it's telling me to add 1 3/4. Is that the same thing as 1 plus 1 plus another 3/4? Yeah. Okay, so if I add 1, what number am I at now? 2. Okay, so when I add 1, I'm at 2. So I've done 1 plus 1. What do I have to add now?
3/4.
So am I going to move all the way to 3?
No.
I'm just going to move 3/4 of the way. So I'm going to move 1/4, 2/4, 3/4. And that's the plus 3/4. Make sure you label this plus 1 and plus 3/4 so I know what all your jumps are. So here's 2 1/4, here's 2 2/4, here's 2 3/4. So what's my final answer? 2 and, because my dot ends up at the 2 3/4 mark. So therefore, 1 plus 1 3/4 is equal to 2 3/4. Now, this question asks us to do 2 3/10 plus 3. I have a question over here. It says, how could we use the commutative property to help us make this question easier? Well, is 2 3/10 the same thing as 2 plus 3/10? Do you guys agree? And then I have to add 3, right? So 2 3/10 plus 3 is the same thing as 2 plus 3/10 plus 3. Do you agree? Yeah. Now we know there's something called the commutative property of addition. When your parents commute from home to work, what are they doing? Are they changing locations? So the commutative property of addition tells us, can we change the locations of those numbers? Yes. What if we thought about it like this? 2 plus 3 plus 3/10. Would we still get the same answer? Yes. Yeah, we've just commuted those terms, those numbers, into different places. And the commutative property of addition tells us we can do that. This is easier because we can think about, make our whole number jumps and then make our fraction jumps at the end. Do you see how that works? So let's try it. What number are we starting at? Are we starting at 0? What number are we starting at? 2. So we'll start at 2. And we have to add how many to 2?
3.
So 1, 2, 3. When we add 3, we'll be at what number? 5. Now we have to add what?
3/10.
So I have to split this into 4, 5, 6, 7, 8, 9, 10 little sections, right? And how many of them are we going to jump? 1, 2, 3. So this is plus 3/10. So at the end, our final answer is going to be what? At this, where my dot is, on the number line, what is that? 5 and, everyone? 3/10. So therefore, our final answer, 2 3/10 plus 3 is 5 3/10. Some of you are thinking, Miss O, I could do that in my head, right? Obviously, 2 plus 3 plus 5 3/10 is 5 3/10. However, today, if you can see our learning goal, we're learning how to use a number line to show on the number line that we're ending up after making those addition jumps at 5 3/10. When we subtract, are we making it the value larger or are we taking it away? Taking away. So which direction are we going to be moving on the number line when we see subtraction? To the left. To the left. Very good. Okay. Now, let me ask you a question before we even do this. If I have 1, and I'm going to take away 1/4. What 2 whole numbers will your answer be between? Is it going to be, if I start at 1, right? If I start at 1, and I take away 1/4. Is my answer going to be between 1 and 2 or 0 and 1?
0.
That's something I always want you to start asking yourself. It helps you understand if your answer is reasonable or not. Before you even solve it, before you draw any pictures or do any calculations, ask yourself, I think my final answer is going to be between 0 and 1. Okay? In this case, what number are we starting with? 1. So draw a little dot at the 1, and we're subtracting, so we're going to be moving to the left. Are we moving back one whole number?
No.
Only 1/4. So split it into fourths, and then we're going to subtract 1/4. What number am I at now on the number line? Well, here is 1/4, 2/4, and here is 3/4. So my final answer, 1 minus 1/4, is 3/4. Was that in between 0 and 1 like we predicted? Yes, it was. I'm going to be starting at 2. Now, if I'm going to subtract or take away 3/5, it's going to be somewhere over here, isn't it? Is my answer, my answer will be between what two whole numbers this time? Between 1 and 2. Thinking about the number line, I know that my final answer will be somewhere between 1 and 2. Okay, now let's do our work. We're going to start at 2, and we have to go back 3/5. That means I have to split the space between 1 and 2 into how many equal size sections? 5. Go ahead and do that. How many lines do you have to draw to split something into 5 equal spaces? 4. Be careful. Yeah, a lot of times people think, oh, it's 5, so I have to draw 5 lines. If you draw 5 lines, how many spaces are you going to have?
6.
Good. So let's draw 4. 1, 2, 3, 4. Okay. And now I have to move back how many of them? 1, 2, 3. Let's label that as taking away 3/5. Now I'm here. Where is that on the number line? Well, my nearest whole number is what? 1. And how many fifths do I have there?
2.
Yeah, because here's 1/5 and here's 2/5. So the answer is 1 and 2/5. So 2 minus 3/5 is 1 and 2/5. And we can use the number line to help us see that. Here we have 3 minus 1 and 2/5. So that's the same thing as 3 minus 1 minus 2/5. Do you guys agree? Can we, you know how we used the commutative property last time to help us?
Yeah.
Can we do that again?
No.
Is there a commutative property of subtraction? Is there? No, there is not. So we can never use the commutative property of subtraction because it doesn't exist, right? So whenever you have subtraction, you have to keep those terms in the same order, okay? Now you might think, wait, but Miss O, 1 and 2/5 is 1 plus 2/5. Why are we subtracting? Well, because we have to take away that amount. So it's minus 1 and then minus 2/5. Does that make sense? So let's take it in parts. We're going to start at 3, and then we're going to take away how much? 1. Once I take away 1, what number am I going to be at? 2. Now I have to take away what? 2/5. That means I have to split the area between, or the distance between 1 and 2 into 5 equal spaces, and I have to subtract, jump down 2 of them. So my final answer will be between what two whole numbers? It's between 1 and 2. We can see that, right? Because 1's here and 2's here. So that means the whole number part of my answer is going to be what? 1. And then from 1, how many fifths do I have to move? 1, 2, 3. So my final answer is 1 and 3/5. Very good. Once again, this is how you can use a number line to show you how to add and subtract fractions with whole numbers.